That makes sense.
Attends, les live Afrique. Ah oui, bah, moi, là. Faut pour moi. So let's go. Attends. 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 See 4 people here.
Okay. All right. Hi guys, happy Sunday. Good afternoon, everybody. I hope you can hear me.
They hear you. You cannot communicate.
Something went wrong.
They hear you.
Okay, so I want to believe you are hearing me. Once again, this is my journey live on YouTube. So we are going to be looking at MATH121 past questions in preparation for your math exams tomorrow. Okay, so the class is starting now. Please, I want you to share the link to your department. Let them join the class live. Are we together? Okay, so I want to start the class. It is so I want to believe you are hearing me. So we'll be looking at revision to MATH121 class, and of course, the course MATH121, cuts across or it talks about calculus, where we talk about functions, okay, and then under functions there are a lot of things you learn under function. Then you finish from function, we talked about composition of function, and then how to find inverse of function. So this is like a revision, and we're going to be dealing with past questions. So you talked about functions, you dealt with limits of function, you also dealt with composition of function, you dealt with inverse of function. Okay, so we talked about limit of function, composition of function, and then inverse of function. And then you also talked about domain of function, and then range of function. We talked about domain of function, range of function, and then we finish from there. We now move to derivative of function. Okay. So what I mean is that these are the areas we are going to be looking at as we are going to be solving the past questions. These are the areas we'll be focusing on, which is very, very important. And then under differentiation, we are going to learn how to differentiate function. I believe these are the things you learned: how to differentiate polynomial function. You equally learned how to differentiate product function. You learn quotient function. You also learned chain function, otherwise known as function of a function. You as well learned implicit function. You also learn parametric function. You equally learned exponential function. equally length, logarithm function, okay, and of course equally length trigonometric function. Trigonometric function. Then this is just under differentiation. Equally, we look at the applications of differentiation to, you know, um, mechanics, that's velocity and acceleration. Also look at extrema of functions, talking about maxima and minima, and of course point of inflation. So these are the things you looked at. And then, so this is, I'm going to start the revision with questions that will touch all this area, probably in this first streaming. Then our second streaming, we'll look at calculus, integration and its applications. So let's, please, I want you to share the link to your department. Share the link. Let your departmental people join the class live, as we are going to be learning a lot. Okay.
Okay, tak.
Anyway.
Hindi mo yan, yung patin pa na yaka. So that I don't tell this editing no strong. Okay.
Oh.
Alright. Ngayon pa. Nung may bari sa mga kaibigan no sa.
Please stay tuned. Stay tuned, I'm coming.
Google Foods now. Now they say this girl is not wait for that. Doga tero ki meri sonire mano kwa ngi sonire. Okay. So yaro toso koso. Aro toso koso.
All right. Sorry about the breakdown in transmission. So we continue. Have you shared the link? Please share the link. Let your people join us. Now let's start with the first question in this past question. I'm dealing with 2015, 2016 past question, and that is how to find the limit of a function. So let's say I have limits as x tends to 0 of the function 1 minus cos 2x all over 1 minus sec 5x. Okay, option A says 0. Option B, 4 over 25. Option C, 2 over 5. And option D, minus 4 over 25. Now, how do we solve this? This is limit as x tends to 0 of 1 minus cos 2x all over 1 minus sec 5x. So what do you do? Anywhere you see 0, you put, look at, we have x tends to 0. Anywhere you see x, you put 0. So this is going to be limit as x tends to 0 of 1 minus cos 2 into, you put 0 here, all over 1 minus sec 5 into, you put 0 here. Okay, after substituting, we now say this is limit as x tends to 0 of 1 minus cos 2 times 0 is 0. So that will be cos 0 all over 1 minus. Oh, this thing will stress me. What I want to do now? Okay. Better. Okay. I hope you guys can see. Check whether you can. Uh, Let me improvise. Check whether you can see. I know what to do. Hmm? Okay, come and help me. Okay, don't worry. Don't worry.
Life is on.
Okay.
They say it's better.
Eh?
They say it's better.
Eh.
Uh,
Okay. I hope it's better like this.
they say it's better. No worry, I'm controlling the abyss.
No wahala. Remove. So, but I know they see my face again. Yeah, I will come do. I mean,
Wait, they say they don't see your face.
I don't know.
What the hell is it?
Okay. Mhm.
Yeah, it's okay.
You can see my face now, Abi.
Yeah, it's
Eh.
better. Yeah, it's better.
So, okay. So this is 1 minus sec 5 times 0 is 0. Beautiful. From here, we are going to write this to be limits as x tends to 0 of 1 minus cos 0. Now, before now, I believe you may have learned, trigonometry, where you know that, okay, this is important. This is sine graph. When you study this, you discover that the sine graph starts from this is 1, 0, and minus 1. So it's something like this, where you have to know that sine 0 is 0 because it starts from the 0 origin. But cos this is 90 is 1. So what we have is cos 0. That means that the cos graph looks like this, 1, 0, and minus 1, where it starts from 1, meaning that cos 0 is 1 because it starts from 1, as you can see. So that means anytime I have cos 0, the answer must be 1. And anytime I have sine 0, the answer must be 0. Sine 0 is 0. Okay. But what is sec? We know that sec is the inverse of cos. So 1 over cos theta is equals to sec theta. So seeing sec 0 here, it means 1 over cos 0. That's what this place means. Okay. So note that sine 0 is 0 and cos 0 is 1. That is very, very important to note. All right. So if you come back to this place, we are going to have this to be limit as x tends to 0 of 1 minus, what is cos 0? Cos 0 is 1. So you write 1 all over 1 minus, what is sec 0? We know that sec is the inverse of cos, which means anytime I have sec, it means 1 over cos. So sec 0 means 1 over cos 0. All right. So this is going to be limits as x tends to 0 of 1 minus 1 is 0 all over 1 minus, we know that cos 0, look at it, cos 0 is 1. So 1 divided by 1 will give you 1. Then 1 minus 1 is actually 0. So this is limits as x tends to 0 of 0 over 0, which is indeterminate. That means it is not defined. So what are you going to do? It means that one of the ways we are going to treat this is that we are going to apply a rule called the L'Hopital's rule. And what does that rule? Since it gives us 0 over 0, it is indeterminate. And we are going to apply L'Hopital's rule to get this done. So how do we do that? I'm going to clean this since I don't need it. Okay, so we are going to differentiate. So applying L'Hopital rule simply entails that we are going to differentiate this. So this is going to be limit as x tends to 0 of, now note that the derivative of 1 is 0 minus the derivative of cos 2x. By now you know how to differentiate a trigonometric function. In other words, if I have y is equals to cos 2x, that means that the y over the x will be equals to, if you differentiate 2x, you are going to have 2. Differentiate cos, you have minus sine, and then you repeat the trigonometry, the polynomial function here, 2x. That is how to differentiate that. Okay, so that means that the derivative of this place is minus 2 sine 2x all over the derivative of 1 is 0 minus, now the same thing here. How do we differentiate say 5x? Okay, so it's important to note that if y is equals to sec x, the derivative of sec x dy over dx is equals to sec x tan x. That's the derivative of sec x. So that means that if I am differentiating sec 5x, I'm going to have that dy over the x will be equals to, the derivative of 5x is 5. Then the derivative of sec will be sec, that will be sec 5x tan 5x. Then how? This is what I mean. Okay, let me make it more understandable. Let's u, let me write this as y is equals to sec u. In other words, u is equals to 5x. That is what u is. So the derivative of sec u means dy over dx is equals to, the derivative of sec u will be sec u tan u. What do you say? Okay. So if that happens, that means that this is going to be that dy over the x is equals to sec, look at it. Remember, we have, if u is equals to this, that means that the u over the x is equals to 5. The derivative of 5x is 5. So this 5, look at it here, then sec u is 5x. I'll put 5x, and then tan u is 5x. Okay. It's not the derivative of sec u. That's what I'm talking about. Um, uh, shit. I don't know.
Abeg, no, na no hit this thing, this wire. No hit this wire, no. No, don't hit this wire.
Yeah. Is it true? Okay. So we continue. What am I even cleaning self? Come on, this thing don't go. So this is minus minus 5. Remember, after differentiating say 5x, you have minus 5. Then this minus here is this. Then this 5, look at it. Then sec 5x tan 5x. Come on. This thing get us video. So from here, I hope you are following. Okay. Now let us put this thing here. Now let's say that the limit as x tends to 0 of this will now be minus times minus is plus. So that will be 2 sine 2x all over minus 5 sec 5 into 0. Okay, then tan 5 into 0. So that means limit as x tends to 0 of 2 sine 2 into 0 all over minus 5 sec 5 times 0 is 0 tan 0. 5 times 0 is 0. Sorry. No, it's nothing. All right. So 2 times 0 is 0. Sine 0 is 0 all over. Okay. Sine 0 is equals to. So please don't forget 2 times 0 is 0. Then sine 0 is 0. 0 times 2 is 0 all over. Now, sec 0. There's a problem there. There's a problem.
Still have them. Continue.
Problem there, that thing. Because normally sec 0 will still give us 0. Then 0 times everything is still 0, which is still undefined. So that means we have to differentiate again. That question long, we'll come back to it. Abeg. You say wetin? Wetin person talk?
Now,
I'm confused.
yeah, I don't tell us, make me not confused.
I did write something.
No worry, no worry. I did reply them. I did reply.
This is not the past question I needed. This is not the past question I needed.
So let them now revision of what.
You didn't have fun.
Don't collect them now.
Maybe can go with the pictures. Which year? Okay, wait, I'll come and show. Let me come. Okay.
So it's getting hotter.
Sorry, there is a little problem in that particular question. Don't worry, we'll come back to it. But let me just, I will make it understandable, but just don't worry. Let me teach you something else first. Later, we'll look at that. Now let's deal with limits to infinity. After we'll come back to limit to trigonometry. So let's say we want to evaluate limits as x tends to infinity of. Okay. Okay. No worry, I'll share the data to everybody. Okay. All right. Please, this year, that was 2022, 2023. Now I'm going to be a bit fast now. 2022, 2023. We want to find the limit as x tends to infinity of this function. What do we do? It's very simple. Let's go. Now, when you want to find limit as x tends to infinity of a function, ask yourself, what is the highest power of the variable at the numerator? The highest power is 3. What is the highest power at the denominator? It is 4. It's 3 over 4. So since the highest degree of the numerator is 3 and the highest degree at the denominator is 3. This is a kind of proper fraction. It's a proper fraction. So when you want to find the limit of such function as x tends to infinity, all you have to do is let me check the option and read. For instance, okay, it's not. The options are A is 5, B 0, C 30, D 2/3. So please note this. Because the highest degree at the numerator is 3 and that at the denominator is 4, that is 3/4, which is a proper fraction. You don't need to solve anything. You don't need to solve anything. The answer is simply 0. So that's just the option you pick and you go your way. Why? Because the highest degree at the numerator is smaller than that of the denominator. That is a proper fraction. The answer is simply 0. You go your way. Okay, that was 2015, 2016. Now let me give you just one more under that in 2022, 2023, and then we move to another question. All right. So for 2022, 2023, the question says evaluate limits as x tends to infinity of x cubed minus 8 all over x squared minus 4. Okay, this is very simple. The options are option A 1, option B 2, option C 0, option D undefined. Okay, so A is 1, B is 2, C is 0, D is undefined. Undefined. Now, these are the options. How do we solve this? Like I said, when you want to evaluate limit as x tends to infinity of a function, all you have to do is look at the powers of the variable. If you look at this, the highest degree of the variable is 3. So this is 3. All over the highest degree at the denominator is 2. So that is 3/2, which is improper fraction. So when it is improper fraction like this, you don't need to solve anything. The answer is simply undefined. But don't forget that if it were to be 2/3, maybe this is 2 and this is 3, the answer would have been 0. But since it is 3/2, which is improper fraction, the answer is simply undefined. And then you get your answer. So that's how to go about that. Now, if you have any question concerning this, you can drop it in the comment section. I will deal with it. So we are done with this. We move to something else. No. Okay, so still in 2022, we have a question here that says, find the range of the function x plus 2 all over x minus 1. Okay, we have to find the range of this function x plus 2 all over x minus 1. I would have loved to write the options on the board, but because of time, I'm just going to read it out. So A says minus infinity, comma 1 to 1, comma infinity. I think it's important to write it. Okay, let me write the options on the board. It is A is from negative infinity to 1, and that's union union 1 to infinity. That's A. Option B says from negative infinity to 1 and from 1 to infinity. Option C is from negative infinity to 1 and from 1 to infinity. And then option D, from negative infinity to intersection 1 to infinity. Okay, so these are options. I had to write down these options because there's something I need to explain to us as regarding these kind of brackets that are used. They are very, very significant. Okay, now, first of all, we need to know something, that this is f of x, this is a function, and this type of function is called a rational function. What this is, for instance, it is important to know that as far as a rational function is concerned, there are always restrictions as to when it regards the denominator. In other words, for a rational function, the denominator can never be zero. For instance, if f of x is equals to p of x all over q of x, that is a rational function such that q of x cannot be equals to zero. Why? If you punch your calculator, for instance, any number, okay, 0 divided by any number, the answer is 0. But any number, say 2 divided by 0, if you punch your calculator, you will see math error, undefined. That is to say, it does not exist. It does not make sense. So that means that when you're looking for when you are dealing with a rational function, the denominator can never be 0. That's one thing we are trying to say. Now, this kind of question is a rational function, and the question says find the range of the function. So I want to say, how do you find the range of a rational function? Step 1, find the inverse of the function. Find the inverse of the function. Now the next question is, how do we find the range of a function? So you see this function to be y equals to x plus 2 all over x minus 1. Step 2, make x the subject of formula. How do you do that? You cross multiply. So that will be y times x minus 1. That is y into x minus 1 equals to x plus 2 times 1, x plus 2. Step 3. Okay, so remember, no, that's still step 2 because we want to make x the subject of formula. So open the bracket. Y times x is xy. Y times minus 1 is minus y equals to x plus 2. Then I'm looking for x, so I have to collect like terms. In other words, take this x to this side. So I'll have xy minus x. This x will cross and become minus x equals to 2. Minus y will cross and become plus y. Next, x is common here, x is common here. I will factor out one x into, what am I left with here? Y minus, what am I left with here? 1. Remember, I have factored out this x. Okay, equals to 2 plus y. Next, look at the x I'm looking for. So that means that x is equals to 2 plus y all over y minus 1. Y minus 1. Then the next step is to interchange the position. The next thing is to interchange the position of x and y. So that means that here will be y equals to 2 plus this y will now become x all over x minus 1. So it means that f inverse, that is to say the inverse of this function, written as f raised to the power minus 1 of x equals to 2 plus x all over x minus 1. That is the inverse of the function. This is how we find the inverse of this function. Now, step 3. Remember, we want to find, well, we have been able to, is to find the inverse of the function. This is the inverse. To do is to find the domain of the inverse function. So how do we find the domain? Of course, you know, domain has to do with a set of input values of x. That is domain. And range is output, output values of y. Domain, domain D is input values of x, and range is output values of y. So when we say we want to find the domain, we are talking about what are the values of x that will satisfy this function, thereby carefully removing any value of x that will make it undefined. So what do we do? Very important. So then the question is, how do I find the domain of this function? Step 1, pick the denominator x minus 1. Of course, you know that for this function to be defined, the denominator can never be 0. That is to say, x minus 1 can never be 0. Never. Meaning that x can, it cannot be, because you know, if you carry 1, put here, 1 minus 1 is 0, which makes it undefined, and that is not possible. Okay. So what do we do? This one now is called the critical point. And so this, since this one is the critical point, we now put it on the number line. Here is the number line. We have 1, which is from negative infinity to positive infinity. Now we begin to pick values in this boundary to check which one will satisfy this inequality. So first of all, after 1 is 2. Let's pick 2 and substitute here. 2 minus 1 is 1. That means this thing is defined. So this place is okay. But let's pick a number here. Before 1 is 0. Put 0 here. 0 minus 1 is minus 1, meaning that this region is also satisfied. But if you pick this critical point 1 and substitute, 1 minus 1 is 0. That means 1 is not satisfying this equation. This point is not defined. So that means that the domain of this function will start from negative infinity to 1. But you know that 1 is not inclusive. Hence, you use an open bracket like this. Of course, you cannot close infinity, so it is like this. And union means and. From 1 to positive infinity, from 1 to positive infinity. Please note, 1 is not inclusive, so we use an open bracket, and you cannot close infinity, use open bracket. So this becomes the domain. This is the domain of this rational inverse function. So what is then our final answer? All right, let me conclude it like this. We're looking for the range of this rational function. So I said the first thing you must do is to find the inverse of this function, and this is the inverse of this function. Then we now find the domain of the inverse function, the domain of this inverse function. Look at the domain here. So this domain of the inverse function becomes the range of this given function here. So this is the range of this rational function. And the correct option here is option C. Why is 1 not the option, the first option here, not the correct option? Is because this bracket here, square bracket, shows that 1 is inclusive in the solution set. But this one shows that 1 is not inclusive because it is open. So the correct option is option C. You can still drop your comments on the comment section there. but this is the solution to this particular problem. All right, so we move to the next question. Let me see.
I'm gonna send you for the